All right, so we'll say, for example 1, we're going to do y equals negative sine of 5x plus 1. Negative sine of 5x plus 1. So can you guys tell what the amplitude is? Amplitude is 1. All right, what's the period of the graph? 2 pi over 5. Okay, are there any other transformations? It goes up 1. And if it goes up 1, that also means that that's where the midline is. So the very middle of the graph is going to be at positive 1. Okay, so midline. All right. So I'm going to go ahead and I'm going to use my marker to draw my x and my y axis so that if I mess up my graph, I can just erase it because that part will be in pencil. Okay, so I know that my amplitude has to be 1, so I have to be able to go up and down 1. Yes? Yes. The negative means it's been reflected over the x-axis. So I have an amplitude of 1. That means I have to be able to go up and down 1. And my graph has also shifted up 1, and so that means I need a little bit more above than I do below the x-axis. Okay, so when I start graphing this, I'm just going to leave, so you can see I left a little bit of room above the x-axis so that I could do my amplitude of 1, but then I also had space to shift it up 1. Okay. All right, and then what did I say about how I normally draw the period of my graph when I first do my axes? You remember what I said? I told you how many boxes I do, and I said why. I do sets of 4, and that's because we're going to divide it in half and then divide it in half again. So do you guys want this to be worth 4 boxes or 8 boxes or 12 boxes? What do you think? It really doesn't matter. You just got to pick. 8. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put 2/5 right there. So if 2/5 was 8 boxes, then how many fifths would be 4 boxes? 1/5, right? Okay, 1/5 would be 4 boxes, 2/5 would be 8 boxes. So I'll count 1, 2, 3, 4 boxes more, and that would be 3/5. 1, 2, 3, 4 boxes more, and that'd be 4/5. Okay. So at this point, I'm going to switch colors. I'm either going to use a new marker or I'm going to use a pencil or something. And now I'm going to go ahead and I'm going to draw my midline. So my midline is at 1. And since this graph did not shift to the left or right at all, I'm going to draw this line right here on the y-axis. It's just going to stay in the same place. And I should have labeled these. I'm going by ones. So that's -1, that's +1. Okay. So if we can picture a normal sine graph, pi, 2 pi, a normal sine graph starts at 0 and ends at 2 pi. In the middle it hits pi, and between the first two it goes up to 1, and between the second two it goes down to -1. So that's a normal sine graph. Okay? So we are going to draw a sine graph that still has an amplitude of 1, so it's still going to do 1 away from the middle, but it's reflected over the x-axis, which means instead of going up first, it's going to go down first. Okay? So, and this one, it does not have a period of 2 pi, it has a period of 2 pi fifths. All right, so I'm going to start at 0, and I'm going to end at 2 pi fifths. because that's how long the period is. And then just like a normal sine graph, I start at 0, I end at 0, I hit 0 in the middle. So I'm going to touch 0 in the middle. And then normally between the first 2 points we'd go up to 1, but ours is reflected. And so between the first 2 points I'm going to go down 1. And then normally between the second 2 points I'd go down 1, but I'm going to go up 1 because it's been reflected. And then I'm going to go ahead and do that pattern again. So begin, it ends 2 pi-fifths away from where it began. It hits 0 in the middle. Between the first 2, it went down 1. Between the second 2, it went up 1. And then I make sure that this graph is nice and curved. It should not look like V's. So this is kind of like a U shape right here. There's my upside down U shape, upside down U shape. How do your brains feel with that? Okay. All right, here's another example. We're going to do y equals 2 sine of 2x plus pi fourths minus 1. All right, what's the amplitude for this graph? 2. What's the period for this graph? Pi, so 2 pi divided by 2 is just pi. Now, I have to stop before I say more transformations because what's wrong with this? It's not factored, okay? So I'm going to say take the 2 out. And if I take the 2 out, that just leaves me with an x. If I do pi fourths divided by 2, what do I get? Pi eighths, okay? I'm going to say plus pi eighths, okay? And then I still have that minus 1 on the end. All right, so now I can go ahead and say some more transformations. So what else do we see? Left pi eighths. Okay, and then last one, down 1, and that's also the midline. Okay. All right, so I want to make sure I have enough room to do an amplitude of 2, so up 2, down 2, but then once I have that, I have to think about my graph shifting down 1, so I have to have a little bit more underneath the x-axis than I do above. All right. So I'm going to go ahead and start drawing this. Why did I start with this a little bit to the right of the one that I had before? So we're going to shift it to the left, okay? So I'm going to leave myself just a little bit of room. So when we figure out what our boxes are going to represent this time, we have to keep in mind that the period is pi, but we're going to shift left pi eighths, okay? So if we have a period of pi, do we want that pi to be 4 boxes, 8 boxes, 12 boxes? But keep in mind, you are going to be shifting left pi eighths. So how many boxes should we use for pi? Probably 8, because then pi eighths would be easy to move, okay? So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, and put a pi there. 1, 2, 3, 4, 5, 6, 7, 8, and put a 2 pi there. So that means that 4 boxes would be pi halves. What would 2 boxes be? Yeah, 3 pi halves over, 3 pi halves over here in the middle one. What would 2 boxes be from 0? Pi fourths. All right, so I'm going to count up to -2. Okay. All right, so I'm going to switch colors. My midline is going to be down 1, so I'm going to go ahead and take my pencil and draw a midline at down 1. And I'm going left pi eighths. How many boxes is pi eighths? 1. Okay, left pi eighths. So I'm going to draw this sine graph pretending that it starts right over here, okay, because I've done those transformations. So when I do my sine graph, I'm going to remember that I start at 0 and I end at 0, and I hit 0 in the middle, okay? So I'm going to start at 0. Now, because I shifted left, I can't go over to pi because that would be a little bit off. So what I'm going to do is I'm going to count 8 boxes because I know 8 boxes is how far the period was. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my beginning and my end. And I'm going to put a dot at 0 in the middle. So that's 4 boxes. And then since this graph has not been reflected upside down, then I can do what's normal for a sine graph. So normally sine goes up to 1, but we have an amplitude of 2, so we're going to go up 2. Okay? So between these first 2, right in the middle, I'm going to go up 2 boxes. Between the second 2, I'm going to go down 2 boxes. And then I'm going to do that pattern again. So from here, I'm going to count 8 boxes. So there's my beginning, there's my end. In the middle, I'm going to cross 0 again. So I've got beginning, I've got end, I've got middle. Between the first 2, I'm going to go up 2 boxes. Between the second 2, I'm going to go down 2 boxes. And then I'm going to make sure when I draw those, they're kind of U-shaped. As we're doing this, are you guys coming up with any questions or anything that doesn't make sense? Anything you're wondering why we do it that way? No questions? Questions? Yeah, we'll do some cos ones too because I know those feel different. Okay. We're feeling okay with this? Because if this is the first time you've ever seen it, this is a lot to do all at once. All right. Do we want to see another sine one before we switch over to cosine? Another sine one would be good. Okay. Let's do y equals, do you guys want this one to be reflected or be normal? Reflected, okay. Do you guys care about the amplitude? Small number, big number? Big number? Like, how big? 4. All right, you guys chose it. And then we're going to do sine. I'm going to do... I'm going to say pi halves x plus We'll say pi halves x plus pi halves. And then we'll do minus 1. All right, so the amplitude is 4. The period you're going to have to think about for a second because it's kind of weird on this one. So how do we calculate the period? 2 pi divided by pi over 2. So we're going to do keep it, change it, flip it. So 2 pi times 2 over pi. What happens with the pi's? They cancel. What's the period? It's just 4. That's kind of strange. So the pi went away completely. Okay. Can we see the rest of the transformations when it's written like this? Nope, don't like it written like that, so we have to factor it. So I'm going to take the pi halves out. And when I take the pi halves out of this one, I just get x. What do I get for the other one? Plus 1, yeah. And that's because it's pi halves divided by pi halves, so you have the same thing divided by itself, which is why it becomes 1. Okay. So what other transformations do we have? So down 1 for the end. What about for this part? Yeah, so down 1 and then also left 1. Okay. So amplitude of 4 and down 1. That means I don't have very much room for this. I might have to erase some of that work I did. Okay. So 4. Yeah, very good. Okay, so I'm going to say 1, 2, 3, 4. 1, 2, 3, 4. And you'll notice I left space to go down to -5, and that's because my whole graph is going to shift down 1. So I gave myself enough room for that. The period of the graph is 4, so do you want to count each box as 1? Or maybe we could count 2 boxes as 1. What do you guys want to do? Each is 1. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So this graph is kind of weird because there's no pi's in there. But the period of the graph made it so we kind of got rid of the pi's, which just makes this one an interesting problem. Okay, so that's labeled. Now I have to take my other color and I'm going to show that my midline is down 1. And then I'm also going to show that I went left 1. Okay. So what do I do from there? Yeah, I plot my points, right? So I think about a normal sine graph. A normal sine graph is going to start at 0. And then this one has a period of 4. So we're going to go to the end of the period. So 1, 2, 3, 4. There's our other dot. Now what do I do? Put a dot in the middle. Okay. So on a sine graph, normally between the first 2 points you would go up 1. That's normal. But our graph has an amplitude of 4 and it has been flipped upside down. So between our first 2 points, instead of going up 1, what are we going to do? Down 4. So between the first 2, we're going to go down 1, 2, 3, 4. Between the second 2, we're going to go up 1, 2, 3, 4. And then we're going to do that same pattern again. So I'm going to count 4 boxes, beginning 1, 1, 2, 3, 4, and the end. In the middle, I'm going to put a dot. Between the first 2, I'm going to go down 4. Between the second 2, I'm going to go up 4. And then I'm going to make sure I connect these with U's. You feel like you're catching on? No. All right, let's go ahead and flip our papers over and try a cos graph. Okay, so I'm going to do y equals 2 cos I'm going to do 3x plus, no, I'm going to do minus. We keep moving to the left. Let's move to the right this time. 3x minus pi halves. All right, so what do you guys see about this one? Amplitude of 2. The period is 2 pi over 3. And it goes to the right pi halves? No. Not to the left pi halves. Factor it. Gotta factor it. They tricked some of you. All right, took the 3 out. So pi halves divided by 3 is pi sixths. Okay, so, and then this one goes to the right, pi over 6. If this graph does not go up or down at all, then where's the midline? 0. Okay, so I'm going to say midline is 0. Okay, so let's go ahead and draw this. We need to have enough room for an amplitude of 2. We're not shifting it up or down this time. How many boxes do you guys want to use for 2 pi thirds? 4 boxes, 8 boxes, 12 boxes? 4? 1, 2, 3, 4. 2 pi over 3. 1, 2, 3, 4. So if 4 boxes is 2 pi over 3, then what would the next 4 boxes be? 4 pi over 3. Good. And 2 and negative 2. If 4 boxes was 2 pi over 3, then what's this right in the middle? Pi over 3. You were right. 2 pi over 6 and pi over 3 are the same. So this would be pi over 3. How many boxes would be pi over 6? 1, right? 1/6, 2/6, right? And 2/6 and 1/3 are the same. Okay, so we have a midline at 0, which means I'm drawing on top of this right at 0. Midline right here at 0, and we're moving to the right pi 6, so we're moving this one to the right. So I'm going to look at my cos graph for reference. A cos graph starts up at positive 1 and it ends up at positive 1. And in the middle it dips down to negative 1. And then between those points it crosses at 0. And it looks like a V-graph, but it's not. It's still, we still have to think about connecting those points using U's. So we have to be careful when we draw these cos graphs. Ms. Rice, do I have to memorize these? Yes. Okay, the little bitty graphs that I've been drawing in the corner, those ones you should have memorized. Okay, because they'll help you be able to do the rest of them. And this right here is an arrow with a little space. Okay. So for the graph that we are drawing, we're not going to start up at 1. What are we going to start up at? 2, because we have an amplitude of 2. So I'm going to start up at 2, and then we said that our period was going to be 4 boxes. So I'm going to count 1, 2, 3, 4 boxes, and I'm going to go up to 2 again. So start at 2, end at 2. What should happen right in the middle? I'm going to go down to -2, okay? So right in the middle, I'm going to go down to -2. And then what has to happen in the middle of these points? We have to hit 0, cross it, okay? In the middle of those 2 points, we're going to cross 0. And we're going to do the pattern again. So I start at 2, I count 1, 2, 3, 4 boxes, and then I end at 2. Right in the middle, I'm going to go down to -2. And then between these points, I have to hit 0. And between these points, I have to hit 0. And I draw my graph using U shapes. And last night I said in the video you should make sure when you're done with your graph that you can trace it, and when you trace it your finger just repetitively goes up and down. If you stutter with your finger when you trace it, it means you made a mistake, which usually means that you messed up like the symmetry of the graph if you stutter, okay? So just make sure that your finger just smoothly traces it, okay? All right, how we doing? You guys are very quiet. I can't tell if you're quiet because you're bored, or if you're quiet because you're like, what is going on? A little bit of both? Okay. Let's do one with a negative in the front, okay? Do you guys have a preference for what amplitude we do this time? Okay, y equals -3 cos. Are you tired of the left and the right shift, or should we do another one of those? Another one of those? Okay, do we want to have a left and right shift where it still has pi in it, or should we do one of the graphs where the pi's go away? Pi's go away? Okay. So for this one, let's go ahead and let's do pi x plus pi thirds. And then, should we shift it up or down? Yeah, down, shift it down, shift it up. Up 7? You want to do an amplitude of 3 and then shift it up 7? I mean, we got the whole rest of the page. Up 1? All right. I mean, we can do up 7 if you want. You can draw 7, yes. Okay, so let's just do 1 then. Okay, so yeah, why do you want to do 7 then? All right, so the amplitude is 3. The period of the graph is 2, right? Because we're going to do 2 pi divided by pi, and the pi's cancel. Do I need to show that I did that? Yeah. So we would have 2 pi divided by pi, because that's the pi right there, and they cancel, so the period's just 2. And it shifts to the left pi thirds? No. We have to factor it, right? So I'm going to factor out the pi, and what do I have? X plus 1/3. Oh, Miss Rice, why did you do that to us? That's a fraction. All right, so we're going to say left 1/3. What else do we have? Up 1. Okay, and that's our midline. Our midline is up 1. Okay. All right, so let's start drawing our graph. We have to have enough room for an amplitude of 3, but we also have to be able to shift it up 1. So amplitude of 3 and shift up 1. So my y-axis is good. On my x-axis, I have to think about how should I draw my period of 2 if I'm going to be shifting it to the left 1/3. So sets of 4 may not be the best for this one. Maybe sets of 6? Would a set of 6 work? Yes. Why did I put a 4? Yeah, I was just making sure, yeah, because I was like, normally it would have gone up and down 3, but since it has to be shifted up 1, then I went all the way up to 4. All right, so we're thinking if we do 6 boxes for the period of 2, then a shift of 1/3 would be easier to draw. Okay, because that's a 3. Okay, so we're going to count 1, 2, 3 and put 1, 1, 2, 3 and put 2, 1, 2, 3 and put 3, 1, 2, 3, negative 1. So you might have noticed that one of the hardest things this unit is thinking in fractions. Have you noticed that? The fractions have like come up repeatedly. Have we seen that? So it's a little bit better for you, instead of fighting the fractions, to just kind of accept it's going to happen and then start to learn to work with them. That's what's in your best interest. Okay, so if we look at this one, we are going to go up 1. So I'm drawing my midline of 1. I just counted 3 boxes, but you don't have to draw that if you don't want to. If you don't have enough room, that's okay, because we're not going to go all the way over to it. And then we're going left 1/3, and how many boxes is 1/3? 1. It's 1 box. So left 1 box. Okay. So we're picturing a coast graph. A coast graph normally starts up at 1 and ends up at 1. We have an amplitude of 3, and our graph is upside down. So what are we going to do? We're going to start at -3, and we're going to end at -3, okay? So I'm going to look here. I'm going to start down at 1, 2, 3, -3, and then I have to count out how long the period of the graph was, which was 6 boxes, and then I have to do the other -3. So 1, 2, 3, 4, 5, 6, and the other -3. Okay, so I have the beginning and the end. Now normally in the middle it would dip down 1, but for us in the middle, what's it going to do? It's going to go up, how many? 3. All right, and then what does it do between these? It crosses at 0. Now we have to be careful because these are only 3 boxes apart from each other to the left and right. So where's it going to cross 0? At 1.5 boxes. So right here, that would be right in the middle of this space. Okay. And then same thing for this one, right in the middle. So the reason, you can see now, the reason why I normally do 4 boxes or 8 boxes is because then I don't have to have decimals when I cut it in half twice. But on this one, doing 1/3 with 8 boxes would have been hard. Doing 1/3 with 4 boxes would have been hard. So here I'd say I'd rather do the middle of this than have to deal with 1/3 with 4 boxes or 8 boxes. So you just kind of pick which one would make it easier or harder for you, okay? So I'm going to do the same pattern again. I'm going to count 1, 2, 3, 4, 5, 6, because that was the whole period of the graph. And then right in the middle, I'm going to be going up 3. And then right in the middle of these, I'm going to cross at 0. And then we're connecting these with some nice U shapes. How are we feeling? Can we try some on our own? I will say we've done more difficult ones than I put in your packet. The ones in your packet are not this bad. So if you look in the packet, it asks you first to write down the amplitude, the period, and then vertical and horizontal shifts. So if it went up, down, left, or right. And then after that to go ahead and graph it on a sheet of graph paper. And so we'll see how far we get, because we only have 20 minutes left. We'll see how far we get in the period, and then I'll let you know how many I expect you to graph. Okay? Sound good? Thanks, Miss Rice. Marvelous.